Okay, everybody, we are going to start in on chapter 10. And the program I'm using to post these videos, I'm going to have to do them in parts because otherwise the file is too big. So let's go with part 1. We're going to be in chapter 10, which is mass wasting. This shows you a picture of some landslides that happened in Brazil back in 2011. So to kind of give us a start, mass wasting, also known as mass movement, is basically the downslope movement of material. And that downslope movement occurs under the direct influence of gravity. So that movement is going to involve material at the surface. It is also going to be aided by weathering. Water is going to play a part, but gravity is the most important. Most of our major landslides are those that have natural causes, but now landslides can have man-made causes also. And as we see as we go through this chapter, the rates can go from very small to very rapid. You can see in this picture of the amount of material that's blocking this highway. This is in the Cascade Range in Washington State. So let's go over some basis of mass wasting. So in order for mass wasting to occur, mass movement to occur, your gravitational force has to exceed the resisting force on a slope. Shear strength is going to try to resist that movement. Okay, so when you're looking at shear strength, you're taking into account of the slope's material strength as well as the cohesion. Cohesion is when you have like molecules sticking together. It's a mutually attractive force. You're also going to be concerned with the internal friction between the grains. Are the grains touching? Or the grains suspended in water and not touching? And then you're also looking at any external support of the slope. You can see in this picture, you're being shown that gravitational force is pointing down. You can see you have a component of it acting parallel to the slope. And then look at the shear strength. You're looking at how the grains are compressed. You're looking at the internal friction. Notice that these grains shown right here are touching. So both of those things refer to the cohesiveness of the grains. Now, like we just saw in the slide, gravity is going to operate vertically, but it also has a component of force that acts parallel to the slope. So if my slope is steep, it's going to have an increased force of gravity. We have something that's known as the angle of repose. So that's the steepest slope that a hill can maintain without collapsing. Unconsolidated sediment ranges from somewhere between 25 and 40 degrees. So different material is going to have a different angle of repose. For example, I'm telling you fine sand is about 35%. Coarse sand is about 40%. Angular pebbles would be about 45%. So basically, if you wanted to build a house on a mound of fine sand and you wanted to slope that mound of sand at 40 degrees, well, it wouldn't be stable. That sand would collapse until it reached 35 degrees. Now, we say slopes are in dynamic equilibrium. So dynamic equilibrium means changing. Okay? So they're constantly adjusting to new conditions. There are 7 factors that affect mass wasting. So let's look at some of these factors. First, we're going to look at slope angle. So that's going to be the major cause of your mass wasting. Okay? Steeper the slope, the less stability it's going to have. What could make that slope get steep? Well, waves, streams can do it, and if I take and I excavate for roads and buildings. So if we look at these next few pictures, we can see in this first picture right here, we see undercutting by a stream. Okay, it's removing the base of the slope. In this picture right here, we can see how the slope angle has increased once I've removed that base. And in this picture over here, you can see how stream erosion is actually cause slumping. So this part right here was actually up here, and it is slumped down. In this picture, we're looking at a sea cliff in California, and it was undercut by waves. So you had the direct action of waves, and it's actually eroded away this cliff. This house, part of this house was over here, and it was washed away. In this slide shows our slope angle in regard to highway excavations. So here we can see we have our first picture of our undisturbed slope. In our second picture right here, we see we've removed a part of the support. Okay, we've over-steepened. And then in this third picture, you can see how this part has fallen into the roadway because of that over-steepening. Another factor we have is weather and climate. So mass wasting is going to be more likely in loose or unconsolidated, poorly consolidated material. This material is more prone to weathering because it has more surface area exposed. Remember, weathering is going to cause materials to disintegrate, to break up, to decompose. So it's going to reduce the shear stress. Some rocks we see are more susceptible to weathering, being sedimentary rocks, or very susceptible. As you go deeper in the tropics, the weathering is going to increase. We also want to look at water content. The more water, the decrease in my slope stability. Water has a lot of weight to it. So that large amount of weight is being pulled downward by gravity. Water's also going to decrease the friction between the grains because now the grains aren't touching. If I'm not touching, I'm not going to have friction. What we see is a lot of our clay, our platy particles, are a main cause of our slides. Another thing is vegetation. The more vegetation I have, the more stable my slope is. So vegetation can absorb the water from a rainfall. It's not going to fall on the ground. Roots of plants or trees, they'll stabilize that grain, that soil, so it's not going to erode away. But if I remove that vegetation, whether by human or natural activity, I'm going to increase the mass wasting, as we have seen by the fires in California. Overloading can be another example. Now, usually overloading is caused by human activities. I might dump into an area. I might put a lot of fill in an area. I might build a big septic tank or water my lawn a lot, dump building materials. So basically what I'm doing by overloading, I'm increasing the weight. When I increase the weight, I'm going to decrease the shear strength, and that's going to weaken the slope. I could also look at the geology in terms of slope stability. So topography, this word right here, means configuration of the land surface. Am I dealing with flat land? Am I dealing with hilly land? Am I dealing with mountainous land? Those two, topography and geology, are very important. If my rocks underlying a slope dip in the same direction as the slope, my mass wasting is going to be more likely. Water will percolate into the bedding planes and they'll just slide, like a slip and slide would be. That would increase the mass movement, the mass wasting. And then finally, triggering mechanisms. So most of my mass movements are triggered by something, by some type of force that's going to disrupt the equilibrium. The most common triggers would be earthquakes, heavy rainstorms, snow melts. Now, I don't always need a triggering mechanism, and I don't always need a triggering mechanism to be natural. Humans can also provide that triggering mechanisms. Okay, this is going to be the end of part 1 of chapter 10.